guys, so this video is a continuation. It's 4.2. I did 4.1 on the previous video. Please check it out in the description of this video if you're watching from YouTube. Please browse if you're watching from TikTok. It's a June 2023 past paper that was written by Matric. So if they are watching this video, please tell them not to watch. I don't want them to be stressed out. Anyways, let's continue. Now 4.2.1. If you take a look here, we're given this function here, and it is a hyperbola. Hope you know a hyperbola, right? It has two asymptotes. So the general formula for hyperbola is y is equals to a over x plus q, right? So let me say x plus or minus p. So that is a hyperbola, standard form of a hyperbola. So this is a hyperbola. So we're just going to solve this out quickly without a waste of time. Please note that I'm just going to spend at least 10 minutes because that's the restriction of TikTok. Write down the equation with asymptotes. So looking at this problem here, the equations, it's this one here and this two here. So 4.2.1, I'll say x, which is the vertical asymptote, it's equals to 1. Y, which is the horizontal asymptote, it's equals to 2. So we are done with this one. And 4.2.2, calculate the x-intercepts. We have f of x equals to 4 over x minus 1 plus 2. Let me move the video like this. I hope you can see clearly. So now the x-intercept, y is equals to 0, right? So 0 is equals to 4 over x minus 1 plus 2. Transpose the 2 to the other side. We have minus 2 is equals to 4 over x minus 1. Cross multiply, we have minus 2 into x minus 1 is equals to 4. Divide by minus 2 both sides. We have x minus 1 is equals to minus 2. Transpose the 1 to the other side. We have x equals to minus 2 plus 1. X is equals to minus 1. So this is your x-intercept. X equals to minus 1. So if you write it in coordinate form, minus 1 and 0, right? We are done for this problem here. Ooh, it's 2 marks. Oh, I'm sorry about that. I was hoping for at least 3 marks because it looks longer. Anyways, so now we're going to do 4.2.3. 4.2.3, we also sketch the function indicating all asymptotes and intercepts, right? So to sketch a hyperbola, you need to note the following, right? We look at the equation, y is equals to 4 over x minus 1 plus 2, right? So this is the a value. It tells you where the function is, so it's the a value. When a value is greater than 0, it's in the first and third, right? We agree on that. First and third quadrant. First, third quadrant. And if a is less than 0, it's in the second and fourth quadrant, right? So it's here and here. So in this case, our a is greater than 0. So it's in the first and third quadrant. So the first thing we're going to do is going to indicate our asymptotes. Oops, let me just erase this. So we're going to go to indicate our asymptotes. I don't know why I'm speaking like this. So indicate our asymptotes. Our asymptotes, we know it's x being equals to 1, y is equals to 2. So indicating that x equals to 1 is here. You indicated x equals to 1, please. And then y is equals to 2, it's somewhere here. Y is equals to 2. And then you remember our x-intercept from the previous question. It was equals to minus 1, right? So my x was equals to minus 1. It was somewhere here. Please note this is not a, I'm just trying to indicate minus 1. Let me erase it because someone is going to do the same thing. So minus 1 and 0 is here, right? So it's minus 1 and 0. And then my y-intercept, let's do it quickly because we need to identify the value of y here. So when y-intercept and x is equal to 0, so here we're going to put 0. So it's going to be equals to 4 over 0 minus 1 plus 2, which is equals to minus 4 plus 2, which is basically minus 2. So meaning here it's going to be 0 and minus 2. So the function will move like this. Let me use a different color. So it's going to move like this. It won't touch the asymptote, and then it moves like this, and then here it's just going to be like this, right? So you've indicated all your intercepts and you've indicated your asymptotes, you get all your marks, 4 marks. And then let's go down to another question. Let me just read quickly because I don't know what time it is. Remember, I have a restriction of 10 minutes. So now we're going to do 4.2.4. Use a graph to determine the values of x for which, use a graph, and I just deleted the graph, but it's fine. To determine the values of x for this, right? So you can use a graph, you cannot use a graph, just so you know. Someone can use a graph, someone cannot use a graph. If you don't know how to use a graph, just do this. X minus 1 is less than or equals to minus 2, right? And then take this 2 to the other side. You have 4 over x minus 1. Obviously, you don't have to, I don't think you have to show this because they said use the graph. That's the instruction. So someone can just penalize you, not give you marks because you use calculations instead of using a graph to find these values here. But anyways, we won't solve for x, right? Because if someone was solving for x, you would say 4 over x minus 1 greater or equals to minus 2, and just do cross multiplication. So you do 4 greater or equals to minus 2 into x minus 1, right? And divide by minus 2 both sides. So you will have minus 2 here. This sign will change, so it's going to be less than or equals to x minus 1. And then you transpose the 1 to the other side, we have minus 2 less than or equals to x, right? And then plus 1 here. So it's going to be minus 1 less than or equals to x. So this would be the answer that you'd be getting if you were doing calculations, right? So which would be correct actually, just so you know. So we're just going to use the graph. The reason why I took the 2 to the other side, I want to show you that this is actually the equation. It's this equation here. Let me remove this x so you can see it's exactly the same. So they're just saying to you, because the entire equation is f of x, right? So f of x is greater or equals to 0. What are the y values when it's greater or equals to 0? Remember the function look like this. I'm just going to be quick. So the function, we had an asymptote here, x equals to 1, and this one here of y is equals to 2, I think. And then we have this here, and then we have, I think it was moving like this, right? So now, what are the values of x when f of x is greater or equals to 0? So f of x is actually y. It's a y values. Where do y values start to be greater than 0? From here going upwards, they start to be greater than 0. And here we had a point which was x equals to minus 1. So when x is greater than minus 1, the function starts to have positive y values, right? Here they're positive y values. Even here it's positive y values. So you can say x greater than minus 1, or when x is greater than this asymptote here, it's 1, right? Greater than 1. Why? Because that's this part here is actually positive y values. So that's how you do it. X is greater than minus 1, or actually let me say equals to here because of this inclusive here, but obviously here I can't say equals to because it's an asymptote. So x is greater or equals to minus 1. Why am I saying greater actually? Just to correct myself, please don't mind me. It's x less than or equals to minus 1 for this one here. X must be less, not greater. What am I saying? So this is the first solution, or x must be greater than 1. So these are the two solutions that you need to write. Yeah. Now let's go down to another question. I hope you did understand. If you didn't, let me know in the comment section. Oops. So let me be quick. You know, I hate it when it cuts me off and I've exceeded the 10 minutes. So I hate that. So now, I hope I'm not too fast. Anyways, let's solve it. Determine the equation of the essence of symmetry of f of x minus 2 that has a negative gradient. So we have of f of x, right, which is equals to 4 over x minus 1 plus 2. But now we need to identify the essence of symmetry for f of x minus 2. So where there's x, we're going to put x minus 2. So f of x minus 2 is equals to 4 over x minus 2 minus 1 plus 2, which is 4 over x minus 3 plus 2 is f of x minus 2. So to find the x of symmetry, that is negative. We know the gradient is equals to minus 1. So it's y is equals to minus x plus c, basically. And then we're going to use the asymptotes. So in this case, the asymptotes x equals to 3, y is equals to 2. We're going to substitute them. Where there's y, we put 2 equals to minus. Where there's x, we put 3 plus c. So to find c, this transpose to the other side, we have 2 plus 3 equals to c, which is equals to 5. And then y is equals to minus x plus 5. So that's how we find the equation of the x of symmetry, which is negative. Thank you so much for watching. If you haven't subscribed, please do subscribe. Please follow if you're at TikTok. I'm going to do question 5 on another video. Check it out.